Okay, hi everybody. So in this video here, we're going to take a quick look at simplifying this rather complicated looking rational expression. But this is an important pattern, okay? The pattern that we're seeing here is a pattern that's going to show up a lot in a calculus course, particularly at the very beginning of a calculus course here. So now I'm not going to give any more context to it than that. We're just going to treat this as if it's a rational here. So notice I've got this 3 divided by x plus h squared plus 1 minus 3 over x squared plus 1. And then my denominator for the whole expression is just h. There's really not much I'm going to do with that. I might write it as h over 1 uh, because it's in the denominator of this larger fraction, and I have a sense that I'm going to multiply by a reciprocal in just a bit here. To combine the two fractions in the numerator, I need a common denominator. And x plus h squared plus 1 and x squared plus 1 do not obviously have any factors in common. So to get a common denominator, I am basically going to multiply the denominators together, which means this is going to end up having to be x plus h squared plus 1 multiplied through x plus h squared plus 1 multiplied through. So it's granted it's a little bit ugly here. So my denominator here right off the bat up there is going to be x squared plus 1 multiplied by x plus h squared plus 1. Whoops, sorry, I didn't need both of those. And then my numerator for that is going to be 3 multiplied by x squared plus 1 minus 3 multiplied by x plus h squared plus 1. Oops. Okay. Boy, that just got busy. It just got really busy. So what I'm going to do is I need to multiply out that numerator. Okay. I got to multiply that all out here. So this is going to become 3x squared plus 1, plus 3 minus, now I'm going to do this in 2 steps just to make sure that this is really clear. X plus h squared will become x squared plus 2xh, plus 2xh plus h squared. And then there's that plus 1 that sits on the outside there. This is going to be all over, and I'm not going to worry about expanding out the denominator right now. There's really nothing to be gained by that. In fact, it is often quite helpful for us to see it in factored form. And this whole thing, and I'm going to write that overall division as a product, is going to be multiplied by 1 over h. And yeah, I knew I was going to multiply by the reciprocal at some point. So now my numerator will become 3x squared plus 3 minus 3x squared minus 6xh minus 3h squared minus 3 all over. I'm going to bring that h in there. So h times x squared plus 1 multiplied by x plus h squared plus 1. And bear in mind here, I'm going to highlight this. Bear in mind right from the beginning that square, okay, that square there sits outside the x plus h. Okay, it sits outside the x plus h. I've seen lots of students that will inadvertently move that square in, but it changes the whole expression once you do that. So you just got to watch out for that. Now, watch what happens here. The 3x squared and the negative 3x squared going to become 0. This 3 and this negative 3 here going to cancel, become 0. And in a pattern like this, you are always left with this expression. And so what I'm left with here is this negative 6xh minus 3h squared. I will always be able to factor an h out. And so I'm left with negative 6x minus 3h all over h, x squared plus 1 by x plus h squared plus 1. And then I'm going to cancel those h's there. And then this will become negative 6x minus 3h over x squared plus 1 multiplied by x plus h squared plus 1. And then the only thing that I need to comment here, the only restriction that I no longer see that exists here is that I have to really state that h cannot equal 0. Okay, I don't see the h in there anymore causing me that kind of a problem, but it did in the previous step, and so I need to state that. And there you go. That's that expression simplified down. I'm not going to worry about the denominator. Like I said, that's not going to be of much help to me right now.